All right, guys, this is the 5.2 and kind of going into 5.3 video. We're looking at some probability rules, some basic probability rules, and some two-way tables. And then in the last video, we'll kind of solidify everything, give you some formulas that we're going to be using. So the first thing here is here's some the probability that a random student who took an AP exam and recorded the student's score. Okay, so here are the probabilities. Here's the scores. What is the probability that a student scored 3 or better? All you're doing here, pretty straightforward, is you're just going to add this probability plus this probability plus this probability, and you get some number. Just add those three together. Find the probability the student didn't get a 1. Okay, that's the same thing as adding up 2, 3, 4, and 5. Okay. Now, one thing you'll notice is that that's the same thing as me going 1 minus the probability of 1. Okay. All these things added together equal 1. So if I take 1 and I just subtract away this guy right here, then I'm just going to be left with the answer. So either way you wanted to do it, it's fine. Okay. This is called a complement. We'll talk about that a little bit. All right, so a couple definitions. What is a sample space? So sample space is the set of all possible outcomes. So for example, like heads, tails, or I guess you can also include the empty, what they call the empty set in there, and the full set. So that's kind of the idea between a sample space. What is a probability model? It's a description of some chance process that consists of two parts: sample space, which we denote with an S, and a probability of each outcome, or for each outcome, I should say. All right, what is an event? It's any collection of outcomes from a chance process. An event is a subset of the sample space. Here I'm going to give you some basic probability rules. So number 1, probabilities are always between 0 and 1. Okay, number 2, all probabilities sum to 1. Number 3, if all outcomes are equally likely, then the probability of an event, which we're going to call A, is, and then we denote it P of A, so the probability of A is equal to the number of outcomes in A divided by the total number of outcomes. So think about it this way. If you're rolling a dice, likelihood is obviously 1/6 for everything. And so say you want to find the probability of a 4 and a 5. So A, your event space A is the 4, 5, right? There's 2 ways of getting that. So 2 out of 6, right? So 1/3. Trying to make sense. Okay. Number 4, the probability that the event does not occur is called the complement, which I mentioned earlier. is equal to 1 minus the probability of that event. We denote this with A, then you can put like a little small c, like a subscript c at the top, or A prime. The last basic probability rule, if he has no outcomes in common, then the probabilities are called disjoint. And so another way of thinking about it is that the intersection is empty. So if I say the likelihood that you're less than 1 but greater than 5, right, and only on one roll, those are going to be disjoint events. Okay, so that leads into this next definition. What does it mean if two events are mutually exclusive? There are no outcomes in common. That is the probability of A and the probability of B both happening equals 0. And so we just write that probability of A and B equals 0. And if you want to think about this visually, you have here's A and here's B, right? There's no overlapping events. So the likelihood that they both occur is going to be none. Right? And a good way to remember this, think of males and pregnancy. Right? It's the easiest example to remember. So those are your basic probability rules. And so now that leads into two-way tables. Two-way tables, just a way of writing down information. We can look at some more probabilities from within this. All right, and yeah, so we can do some of that stuff. So first thing I'm going to do, I'm just going to draw a little table. And here we're looking at the likelihood that you get like free tacos at a baseball game, depending on if you win or lose, depending on the amount of runs you score, or if you just win or lose, and then the runs. So kind of draw this out a little bit. All right, so here's winning. Here's you not win. I'm gonna write it as not win because it's like the complement, but you can also write losing. Free t-shirt. No free t-shirt. Or tacos, not t-shirts, tacos. Okay, free taco, no free taco. All right, now if we read this problem, it says here that the Diamondbacks won 41 games. So on the outsides, we're going to go totals. I'm going to put totals out here. And this is kind of how you set these two-way tables up. So first thing, okay, we know we're going to win 41, or we know the Diamondbacks won 41 games, so I'm going to put 41 on the outside. And we know that there's 81 total home games, so that means I can put 80 down here, or not 80, 40 down here. Right, because this sums up to 81. So then here you have like your grand total of 81. That's the start. And now we can kind of keep reading, keep dissecting more and more information. So next thing we know is that the Diamondbacks gave away 30 total free tacos, or 30 games where they gave away free tacos. Okay. And that means we know that if we add across, 30 plus some number has to equal 50 or 81. So you know this number has to be 51. So we're kind of just filling this in piece by piece. In the 26 of the games the Diamondbacks won, they gave away free tacos. So that means you won and you gave away free tacos. So this goes here, 26. If we know we gave away 30 games of free tacos, we know that this number has to be a 4. And now we're just filling in the rest. This has to be a 36. This has to be a 15. Right? 36 plus 15 equals 51. 26 plus 15 equals 41. And if you add down 26 plus 4, 30. Yeah, and then we're good. So this right here represents a two-way table. So we're just reading the problem, kind of breaking it all down. So now we can answer some questions on this. All right, so now the question is, what's the probability that we simply win a game? All right, well, we won 41 out of 81. Okay, that's the first one. And hopefully you got that table written down, because I'm not going to draw it again, but I'm just going to have references. So here now, the next one, what's the probability that they won a game and there are free tacos? So now you're looking in this top left cell where we had they won and they both give away free tacos. So that's 26 out of 81. And if you want to simplify these down to decimals or percentages, please feel free to do so. And now the next one, what's the probability that the Diamondbacks win or their free tacos? Okay, so here we have 41 wins, plus they gave away 4 additional tacos when they didn't win. So you have 41 plus 4, which is 45 out of our total number of games at home, which was 81. I can write down over here 41 equals wins. 4 equals no win, but gave taco. And so we're just adding those two together. Okay, so now that leads into our first big general probability rule, which is the general addition rule. And so when we denote this with a union. So I'm going to draw this out. So you have the probability of A or B. So A, and we write or with the union sign, so there's a little u. UB is equal to the probability of A plus the probability of B minus the probability of both. So I'm going to write that intersection B. And so again, union is or, intersection, and. So you want to have to think about that. Okay. Last 2 questions in this video. And then, the next video we'll talk about conditional probability, which is a really big concept. So going back to the chart, find the probability that the Diamondbacks win given that there are free tacos. So now when I read these problems, I'm going to look at the given then statement, because that's going to tell me my denominator. Okay. So here, right, given that there are free tacos, so we know that there's 30 games where there are free tacos handed out. Now, out of those 30, how many times do we win? Okay, and this is 26. 26 out of 30. Now, read the next one. Find the probability there are free tacos given that the Diamondbacks win. So now we're flipping around. I was like, okay, given that they won, so here there's 41 games in which they won. How many times did we give away free tacos? 26. And I want you to think about the relationship between these two, and what do you think that could mean? Okay, so think about the relationship between those two. Think about what that means. But this was a really brief introduction into some basic probability rules. As always, guys, if you have questions, please let me know. But if not, have a great rest of your day.